Hello everyone, I just woke up so I'm not gonna have my webcam on today, but I wanted to show you a game, another game that I've been working on using my new engine, and I might also show you some source code to go through how certain things in the game work. So this is actually a game I was making when I went to high school. I made it in Java and I lost all the source code, so I decided to recreate the game again in C now using my new engine. Let me just have a sip of coffee here. So you're basically a some sort of professor, or I don't know, some sort of you're a very smart guy. And you work with electricity basically. And the goal, or the main goal of the game, is to solve puzzles using electricity. Now, there aren't actually any levels and things yet. I'm just working on the game mechanics right now. So there aren't actually any puzzles right now. Well, there's one puzzle here, I guess, when you start, and you're supposed to get out of this room here somehow. And to do that, you can basically you have a small inventory here. So I provided you with some items here. So you're supposed to connect a wire to this door here, and then place out a lever and use electricity to get out here basically. And now there's no other puzzles. So there's only this level right now. And as I said, I'm just working on the game mechanics right now, so I haven't really designed any puzzles yet. And so there are a couple things you can use here. You have a lamp, for example. You can connect a wire to. And yeah, I'm also going to implement a light engine so that you can actually see this one emitting light around it. I haven't gotten into doing that yet though, but it's going to be a real simple shader. Because in my old, when I implemented this game in Java, it actually had a lighting engine and it looks really cool. And also, I remember the electricity had like different like rainbow colors, and they were actually emitting rainbow lights around it. It looked really cool. So I want to try and implement that again. The inventory is sophisticated enough so that you can actually pick the items up again. And you could see there that the electricity in the wire went out. And if I pick up the cable here, you can see that the cable in the inventory number here increases as well. So it's also sophisticated enough to know where to put the wire that you picked up, or the item you picked up. And I also started working on dynamites. Now they don't really do anything yet, but we can explode one here. And that's basically what happens. Yeah, I'm working on those particle effects as well. And I think I limited the electricity to only be able to go 8 blocks or 8 tiles. Because everything is just based on tiles here, basically. So it didn't manage to reach the dynamite entirely. But now if we just turn it off, put the dynamite here. Oh, it didn't reach here either because the electricity stops right here. Let's turn it off. There we go. So yeah, I'm basically just working on this game mechanic right now. And the wire or the electricity algorithm isn't perfect yet either. For example, I don't think I want this to be possible later. And certainly not that either. And I'm thinking about adding other components to the electricities as well, such as maybe a clock chip that makes it possible to create like clocks. So yeah, that's basically it. And it has a simple AABB collision checking thing. It's real simple. Now it isn't perfect either, because I know that, okay, so the world is divided up in chunks, just like in Minecraft, I guess. So in this game, or in this engine, every chunk is 8 tiles, 8 by 8 tiles. So here's actually one chunk, and here's one chunk, and here's one chunk, and here's one chunk. So we're actually seeing 4 chunks here. And the collision checking is a bit buggy at the edge of chunks, but I'm working on that as well. So for example, here it's a bit tricky to get in, because it's trying to do a collision checking in the chunk that you're currently in, and I'm not in this chunk, so it sort of fails. But if I can get in, but it's, I don't know, on this side it's a bit weird. And now I can't get out. So I want to show you how the electricity work. It's a pretty simple algorithm actually. So I think it's in the block.c file. Yeah, here it is. So we have a block update function here. It takes in a pointer to the block that's supposed to be updated and a pointer to the chunk and some coordinates about where the block is. Because this block has no information about where it is actually. If we go into the block.h, it only contains what type it is and what alternation it is, and how much electricity it has, if it's solid, when it was last updated, and a texture. So anyway, here's where it updates the electricity. So first of all, it checks that we're not a block air and that we're not a block lever. And the reason why we're checking if we're not a block lever is because I don't want the electricity to go back into the lever, because then the lever gets flipped off again. Let me actually show you that. So if I remove this check here, we compile it. Now the electricity is going to go back into the lever and flipping it off. We might not be able to see it actually. Yeah, you can see that it flips off again. Because the electricity goes back into it and flips it off. So let's put that there again. So basically what we're doing here, in every block update, first we're setting the charge to 0. And then we're setting the charge to the block that's right to it, that charge -1. And first we're just checking that the right charge here is greater than all the other ones. So if we go into here again, and we actually, let's just compile it again so we don't have that bug anymore. So basically what's happening here is that for every tile here, for example, we're starting with this first tile here, because this is the tile that's getting fired or charged first. It's first doing a comparison of all the tiles around it, checking which tile has the highest charge. And at this point here, the lever is going to have the highest charge, because when a tile is fully charged, it's charged with 8 electricity points. So what it's going to do, it's going to grab the lever's charge, put it on itself -1. So now this charge here will be 7. And then on the tile to the right, it's also going to perform a block update. And that one is going to do a comparison around it, checking which tile has the most charge. And obviously it's going to be this one, because the other ones hasn't been charged yet. So it's going to grab this one, which has the charge of 7, put it on itself -1, so we're now going to have 6 here. So you can see where this is going. The charge is going to decrease the further down we go. And this sort of this applies to every tile actually. So if I wire a cable into this block here, this one is actually also having a charge now. So this charge -1. So yeah, it's really simple. But all of these if statements here, they're basically just comparisons to check that we're actually grabbing the tile with the max charge. And then we're just setting this to the current tile -1. So it's really simple. And yeah, I made all the graphics myself as well. So we can go into, we can do Chromium res image. Actually, let's do EOG res image. So here's the effects sheet. You can see that it has the dynamite explosion effect here. And here's I call this the entity sheet. I don't know. So here's where the player is. I made this graphics as well. Yeah, I made all the graphics. And here's the UI part. And here are the tiles that exist. So we got the stone wall here, and we got the wires, the levers, the lamps, the doors, and the dynamite. So the game is actually 3-dimensional in one sense, because it has a depth to it. It has a depth of 2 basically. So or actually 0, 1, 2. So it has a depth of 3, I guess you can say. No, actually it is 2, so it's 0 and 1. So all the tiles here in the background that you can see that I'm walking on, they are on the 0 index in the world. And then we have tiles on top of them, which are in the 1 index. So actually everything I place out is actually also a tile. Everything here on the screen except for the player is a tile. So that's really simple. I think I can demonstrate this if we go into the main scene here. you can see that here I'm creating the ground tiles, or no, here I'm creating the chunks. Here I am creating the ground tiles. So I'm putting, I don't know why I'm putting a block air here. That seems weird. Oh, okay, I see. So for the 0 index, I'm placing out stones. So that's for the ground. And then for the 1 index, I'm placing out air. So by default, on top of the stones, they're going to be just air. And here's where I'm creating the walls around the player. And it also has a simple algorithm for calculating the color here. So everything that is on the 0 depth is going to have a darker color just to indicate that they are actually sort of in the background. And everything placed on top of it is going to have a brighter color, basically. So yeah, the reason why there are hearts here is because I'm planning to add enemies as well. So that you will have to protect yourself using electricity from enemies. So basically, you could use dynamite to blow up enemies. So yeah, this is just something I've been playing around with in my new engine. I don't know where it's going, but it's pretty fun. The inventory is just a struct of these. So it's a struct that contains a list of inventory slots. I can see that I did a spelling. I spelled this wrong here. Anyway. So that's how that works. It's pretty simple. So, thank you for watching, and I'll see you in the next video.